Hey guys, RandomMathsInc, and today we're going to be talking about the conservation of energy. Now, the theory of conservation of energy states that the total mechanical energy of an object, so the kinetic energy plus the potential energy of an object, that it would stay the same. So obviously there's two types of energy. There's kinetic energy and there's potential energy, which we'll mainly talk about here. Kinetic energy is the energy due to an object's motion, because if an object has velocity, it will have kinetic energy. And what's potential energy? Potential energy is the energy due to the object's position above a surface, maybe the surface of the Earth. When an object's high up, there is something called potential energy. So let's say I roll a bowling ball.
Nice form.
So imagine the bowling ball. At first, it had to go a certain height above the ground. That is when it gains potential energy. And once it's on the ground and it's released, it has no more potential energy because all of that has turned into kinetic energy. However, the conservation of energy only applies if the ball is in an isolated system. There is nothing else interfering with the ball. But there isn't. There is something else that's interfering with the ball. There's loads of other things around the environment that's actually interfering with the ball. And this is what we call external work, which is some kind of work done on the ball to change its internal energy that comes from outside factors. Now, the first one would obviously be the force from myself. I obviously applied some extra force and some extra push force onto the ball. That means the ball doesn't just have its potential energy initially when it's let go. All that potential energy did turn to kinetic energy, but there were also some extra energy done by myself. How do I know that I did work on the ball? Well, what was the equation for work? We discussed this a long time ago.
Work's equation is actually force times distance times cosine of theta.
I applied a force and the ball moved. That means I must have done work on the ball. And there was one other factor as well. Can you guess what it was? That's right, it was the actual alley. Because the alley doesn't have no friction, there are friction on the alley.
Now the ball's still moving, but eventually it's gonna stop because there it is. It stopped because there's friction. That just proves there's friction. I just proved it. There it is.
Now we know that the force of friction and the displacement of the ball is going in opposite directions. From the equation of work equals force times displacement times cosine theta, theta being the angle between the two vectors, the force and the displacement. Both of these being in the opposite direction means the angle will be 180 degrees, meaning the work done would be negative because cos 180 is a negative number. That means friction is actually doing negative work. But that's still allowed. That just means the mechanical energy of the ball is decreasing. I'm taking energy away from the ball. It's like if you're running towards me and I just stop you. That's a resistive force. You just lose kinetic energy and I'm actually doing the work against you. And yeah, that's it. My video on the conservation of energy, and I hope that helps, and I'll see you again soon. Goodbye.